Welcome to the deep dive. Today we're zeroing in on something you might not think twice about normally, but it has a huge impact on your RC car. Ball bearings.
Ah, yes, the tiny titans.
Exactly. Specifically, we're looking at why swapping out those, standard bushings for ball bearings, why that's such a game changer.
It really is.
Our goal today, basically. Understand why these little parts matter so much, what your options are, and how to keep them running smooth. We've got a really comprehensive guide as our source for this one.
It's quite amazing, really. Something so small, physically small, can make such a noticeable difference in how your RC car performs.
Right.
For anyone wanting, more speed, maybe better handling, even just longer battery life, understanding ball bearings is pretty fundamental.
Totally agree. And that's why we're talking to you, the learner. Ever wondered how to unlock that extra bit of performance, that little edge? Ball bearings are a key part of that puzzle. We're going to break down the essentials, try to skip the heavy jargon, and hopefully hit those moments that make you go, huh. Okay, now I get it.
Let's do it.
All right, let's dive in. These unsung heroes.
So maybe the first thing is the basic difference. Bushing versus a ball bearing.
Yeah, what is it?
Well, a bushing works through sliding friction. It's pretty straightforward, just direct contact, parts rubbing against each other.
Okay, sliding friction. Got it.
But a ball bearing, totally different approach. It uses rolling friction. You've got these tiny, hardened, polished balls.
Inside.
Yeah, rolling between an inner and an outer surface, they call them races. And that just drastically cuts down on resistance.
Right. Less friction.
Yeah.
That sounds like it leads to good things.
Oh, definitely. Big gains. We're talking higher top speeds, for one.
Nice.
Quicker acceleration off the line. And here's a big one. Especially for electric RCs, improved efficiency.
Which means?
Longer battery life. You're not wasting as much power just fighting friction.
That's huge.
Yeah.
Battery life is always a struggle.
And it goes beyond just, speed and battery. Less friction also means less wasted energy turning into heat.
Ah, so things run cooler.
Exactly. Your motor, your ESC, the speed controller, they can run cooler. That might even help them last longer.
Okay, that's a good point. Less strain overall.
Less strain on the batteries, too. Could mean they last longer, perform more consistently through a run.
It really is like a chain reaction of benefits, isn't it?
It is.
Now, here's something interesting.
Okay.
You mentioned they act like protectors for the more expensive parts. How does that work?
Yeah, that's a really important point about wear and tear. Bushings, especially the plastic ones you find in some kits, they wear down.
Right.
And when they wear, they create looseness, play, people call it. This slop isn't just annoying. The worn bushing can actually act like sandpaper on your axles or gears or diff out drive.
Ouch. So the cheap part wears out and damages the expensive part.
Precisely. But with a ball bearing, any wear that happens is contained within the bearing unit itself. It shields those other pricier components.
So a small investment in bearings could save you a much bigger repair bill later.
That's the idea. Protects your investment.
Okay, that makes a lot of sense.
Yeah.
And, beyond the numbers, the speed, the battery, there's also just how the car feels to drive, right?
Absolutely. That smoother operation you get, it translates to a more precise feel, more responsive.
Less vibration, maybe?
Less vibration, definitely. Parts move more freely. It just adds up to better handling, a more refined driving experience. Maybe subtle, but drivers notice it.
Okay, so let's just quickly compare them side by side. Bushings, more friction, more wear, lower speed potential, less efficient, not great under load, wear out faster.
Right.
Ball bearings, less friction, less wear overall, higher speed potential, more efficient, handle loads better. They do need some maintenance, we'll get to that, but much smoother. And cost a bit more upfront.
That sums it up pretty well.
Okay, let's shift gears a bit. Tamiya kits. They come up a lot when talking about bearing upgrades.
Yeah, it's almost the classic first hop-up, isn't it? Replacing the stock bushings in a Tamiya kit.
Why is that so common? Tamiya makes good stuff.
They do. Great engineering. But many kits, especially the entry-level ones, come with plastic bushings. It's mainly a cost-saving thing.
And those plastic bushings, they're the weak link.
Often, yes. They generate quite a bit of friction, and they wear down relatively quickly, especially under load, or if grit gets in there, they can even deform.
Deform, like lose their shape.
Yeah, which creates that slop we talked about. In the drivetrain, suspension, not good. Now, some kits might have metal bushings, which are better than plastic.
But still not as good as ball bearings.
Exactly. Still sliding friction. For anyone wanting to get the most out of their Tamiya kit, upgrading to ball bearings is, pretty much considered essential by many, a near mandatory upgrade.
It sounds like a really noticeable improvement. And maybe for newcomers, doing that bearing upgrade is their first taste of like modifying their car.
Absolutely. And when you feel that difference, smoother, maybe a bit faster, runs a bit longer, it's really rewarding.
Gets you hooked.
Totally. It often sparks that deeper interest. Okay, what else can I do? It's kind of a gateway to engaging more deeply with the hobby, with the tech side.
I can see that, but it still makes you wonder, why put bushings in at all? To me, a knows bearings exist.
Yeah, good question. It really comes down to keeping that initial kit price lower, makes the kits more accessible.
Ah, the entry point.
Right. And then they sell the ball bearing sets as official hop-up options. It's an extra sale, a common strategy.
Makes business sense. Oh. Okay, so for someone listening who's got a Tamiya kit, still running those stock bushings, what tangible gains can they expect? Like really expect?
You'll almost certainly see higher top speeds. Maybe not dramatic, but noticeable. Quicker acceleration, too.
Because less power is wasted.
Exactly. Less drag in the drivetrain. You'll likely get longer run times, as we mentioned. And importantly, you're reducing wear on parts like axles and gears. Your electronics might even run a touch cooler.
Sounds like a win-win-win. Now, if you're doing this upgrade, are there places you should start? Or just do the whole car at once?
Good question. A full set is ideal, gets you all the benefits. But if you're prioritizing or maybe doing it in stages, start with the wheels and axles. Definitely. Those bearings take the most direct load, spin fast, and are right there exposed to dirt.
So worn bushings there mean wobbly wheels.
Wobbly wheels, yeah. And they can wear down the axles themselves. Bad news. So wheels first. Then the gearbox or transmission.
Boy there.
Improves power transfer efficiency. Smooths things out. Prevents potential gear mesh issues down the line.
Okay. Wheels, gearbox. What's next?
Differentials. Smooth diff action is key for handling, especially cornering. And then the steering assembly. Bearings there eliminate slop, make your steering more precise.
So even if you don't do the whole car, hitting those wheels hubs especially is really important for stopping dirt getting into.
Yeah, particularly the external bearings, like wheel hubs, exposed axle carriers. They see the most grit. Protecting the shafts there is critical.
Okay, that's practical advice. Now, let's talk about the bearings themselves. What are they actually made of? Does it matter?
Oh, it definitely matters. So the basic anatomy, you've got the outer ring, the inner ring, the balls themselves, and the cage or retainer that holds the balls.
Right.
And the materials used for these parts. Big impact on performance, durability, cost, everything.
Okay, so let's break down the materials. Steel seems like the standard, right?
Yeah.
The workhorse.
Pretty much. The most common is chrome steel.
Yeah.
It's hard, wear-resistant, handles high loads well. Its main drawback, it can rust if it gets wet.
Rust. The enemy.
Then you have stainless steel bearings. Much better corrosion resistance, obviously. Still pretty hard, maybe slightly less hard than the best chrome steel, but great for wet conditions.
So steel's tough, good load capacity, but watch out for rust unless it's stainless. And they need oil, right?
Yeah.
Can be a bit noisy.
Yep, need lubrication and can have some noise. Now, moving up the ladder, ceramic bearings.
These sound fancy, high-tech.
They are. There are full ceramic bearings where everything rings, balls is ceramic.
Wow. Benefits.
Extremely low friction, very lightweight, super hard, totally corrosion-proof. They can even theoretically run without lubricant.
Okay, downsides. Sounds too good to be true.
Well, they're very expensive. And they can be brittle. That hardness means they don't flex, so a sharp impact could potentially crack or chip. Yeah, not ideal for, say, heavy bashing with big jumps.
Right, okay, so maybe not for everyone. Expensive and fragile.
Which brings us to hybrid ceramics. These are much more common in RC.
Hybrid, what's that mean?
Steel races the inner and outer rings, often stainless but with ceramic balls inside. Usually silicon nitride, the gray-black ones.
Ah, so mixing materials.
Exactly. You get a lot of the benefits of ceramic, the low friction, the reduced weight, higher RPM capability because the balls are lighter and harder.
But with the toughness of steel rings.
Pretty much. It's a really good balance. Better durability than full ceramic, run cooler, often quieter than steel. And the cost, while higher than steel, is more accessible than full ceramic. It's kind of the performance sweet spot for many.
Hybrid ceramic. Okay, that sounds like a really popular upgrade path. Now, what about plastic bearings? Are those a thing?
They exist, yeah. Plastic ball bearings. Lightweight, corrosion-resistant, quiet. Some are self-lubricating. But they can't handle high loads or high temperatures, so you won't find them in, like, your main drivetrain or wheel hubs on most performance RCs. Maybe in some very specific low-stress applications.
Got it. So not really for the tough jobs. It really does depend on what you need then. Rust-proofing, stainless or ceramic, big jumps, maybe stick with steel. Racing. Ceramic sounds tempting.
It's all about matching the material to your needs. No single best material for everyone.
Now, you mentioned the cage, the thing holding the balls. Does that actually matter much?
It does, often overlooked, but the cage is critical. It keeps the balls evenly spaced, vital for smooth running and distributing the load properly. It also helps retain the lubricant.
What are they made of?
Can be simple steel or nylon, which is common, but you also see phenolic resins, other specialized polymers. Some brands have their own fancy cage designs claiming better performance.
Huh. So even the cage tech matters. Interesting.
A good cage is definitely a sign of a quality bearing.
Okay, let's really dig into this now. Ceramic versus steel. It sounds like the big debate.
It is a hot topic, for sure. Performance-wise, the main thing is friction. Ceramic balls are inherently smoother and harder than steel.
Lower friction coefficient, is that the curve?
Yep, less resistance, which means more efficient power transfer from your motor to the wheels. People talk about freer movement, smoother transitions.
Sounds good on paper. What about weight? You mentioned ceramic is lighter.
Significantly lighter. Like silicon nitride balls are maybe 40% less dense than steel. Some brands claim even bigger differences.
And lighter means?
Lower overall weight for the car, sure, but more importantly, lower rotational mass. Things that spin up and down.
Like the wheels, axles, stuff in the gearbox.
Exactly. Less rotational mass means the car can accelerate quicker, brake quicker. It feels more agile, more responsive.
Okay, so lower friction, lower weight.
Yeah.
Could that mean higher top speed too?
Potentially, yes. The lower friction and mass allow for higher RPMs. You see claims maybe 10-15% speed increase. But honestly, it depends hugely on the rest of your setup motor, gearing, everything.
Right, it's not magic. Okay, performance sounds like a plus for ceramic, at least the hybrid ones. But durability, are they tough enough?
This is the paradox, really. Ceramic is way harder than steel, excellent wear resistance under ideal conditions. But that hardness comes with brittleness. Like we said, they don't handle shock loads as well. A really hard landing, a big crash.
Could be game over for the bearing.
It's possible they might fracture, or the hard ceramic balls could even damage the softer steel races under extreme impact. So for really rough off-road bashing, maybe not the best choice. Fragile is maybe too strong a word, but less impact resistant than steel.
Okay, so a potential weak spot there depending on how you drive.
Yeah.
What about rust, though? Steel rusts.
Huge advantage for ceramic here, immune to rust and corrosion. That makes hybrids, often with stainless races, fantastic for running in wet, muddy, or humid conditions.
That's a big plus for a lot of us. And heat. Does one handle heat better?
Ceramics generally run coolly because they generate less friction in the first place. They also expand less with heat than steel.
Cooler running?
Huh?
More consistent performance? Longer life, maybe?
That's the theory. Consistent performance and potentially longer lifespan for the bearing itself due to less heat stress.
So putting it all together, do they actually last longer? People claim huge numbers.
You hear things like 5 to 10 times longer life under optimal conditions. That's the key. Depends heavily on the application, the quality, maintenance, and crucially, avoiding those big impacts.
Handle with care, basically.
Pretty much.
Okay, what about maintenance then? Do ceramics need less attention? Can you just ignore them?
Not quite. Steel bearings definitely need regular cleaning, oiling, or greasing to fight friction, prevent rust, flush out wear particles.
Standard procedure.
Hybrid ceramics, well, the ceramic balls don't rust, but the steel races and the cage still do, so they still need lubrication. Usually a light, high-quality synthetic oil is best.
To protect the steel parts.
Yeah, and lubricate the contact points, flush contaminants. Heavy grease is generally avoided with ceramics. It can add drag.
What about full ceramics? Can they run dry?
Technically, yes, their material properties allow it. But even then, a very light specialized oil or a dry lube is often recommended, especially in RC.
Why, if they can run dry?
It can help reduce noise, improve smoothness even further, help keep them clean by flushing stuff out, and offer some protection under load. So the idea that ceramics need no lube, especially hybrids, is a bit of a misconception. They still benefit from proper care.
Interesting. Still need some TLC.
Okay, the million-dollar question then. Cost versus benefit. Are ceramics worth the extra cash?
It really depends. For competitive racing, especially stock classes where motor power is limited, Those tiny efficiency gains can make a difference.
Yeah.
Might be worth it.
Well, high RPM applications like nitro engines, they spin incredibly fast. And, for the enthusiast who just wants the absolute maximum performance, price no object.
But for the average basher,
Probably not essential. Or for someone running a massively overpowered brushless system already, the gains might be less noticeable. Good quality steel bearings are already a huge upgrade over bushings and much cheaper.
so value is really specific to how you use the car.
Exactly. Tangible benefits in power-limited racing or nitro. Less impactful, maybe, in high-power modified or just casual backyard fun.
Makes total sense.
Yeah.
About where that money makes the biggest difference for you. Okay, let's talk about something vital for any bearing.
Seals.
Seals. We touched on them, but they deserve their own focus. Absolutely critical.
Why are they so crucial? Just keeping dirt out.
That's the main job, yeah. Keeping contaminants, dust, dirt, sand, mud, water out.
Mm-hmm.
And just as importantly, keeping the lubricant in.
Right. Gotta keep the good stuff in and the bad stuff out. If dirt gets in, it acts like grinding paste. Wears things out fast, causes noise, makes them rough. Eventually, they seize up.
Game over for the bearing.
Pretty much, especially in RC where cars run through all sorts of messy conditions. Good seals are indispensable. They also mean you don't have to clean the bearings quite as often.
So where are sealed bearings an absolute must?
Heel hubs. Axle carriers. #1 priority. Most exposed, highest load, see the most dirt. Non-negotiable, really, especially for off-road.
Makes sense. Anywhere else?
Any exposed drivetrain parts near the ground. Gearbox internals, too, provide secondary protection, keeps things cleaner inside. Even electric motors benefit hugely from sealed bearings, keeps dust out, helps efficiency and lifespan.
And for off-road or wet running, you want a specific type.
Generally, yes. Rubber-sealed bearings are recommended for those exposed spots in dirty or wet conditions.
Okay, so rubber seals. That brings us to the types. Metal shields versus rubber seals. What's the deal? ZZ versus 2RS?
Right. Metal shields, the ZZ or 2Z type, are non-contact. There's a tiny gap between the shield and the inner race.
So not a perfect seal?
Not against fine dust or moisture, no. Better for larger debris. They have less friction because nothing's rubbing. But typically, you can't remove them easily for maintenance, often considered lubed for life or disposable.
Okay, metal shields. Less friction, less sealing, less maintenance possibility. What about rubber, the 2RS?
Rubber seals are contact seals. They have a flexible lip that actually touches the inner race.
Creating a barrier.
Exactly. Much better protection against fine dust, dirt, moisture. The downside is slightly more friction because of that contact. But crucially, many 2RS seals can be carefully removed.
So you can clean and re-lube them.
Yes. That's a major advantage for maintenance and potentially longer life.
So it's that classic trade-off again, protection versus friction.
Pretty much. For most RC use, especially off-road or dusty conditions, the superior sealing of 2RS rubber seals is generally worth the tiny bit of extra drag.
And ZZ metal shields might be for.
Maybe super clean indoor carpet racing, where minimizing every last bit of drag is the absolute priority. But the quality of the seal matters too. Some are better than others.
And that ability to service the 2RS ones means they could last longer, be more economical in the long run.
Potentially, yes. If you maintain them well. ZZ bearings, you generally just run them till they're rough, then toss them. 2RS gives you the option to extend their life.
Good to know. Seals are definitely key. Okay, now, brands. There are tons of companies selling RC bearings. How do you choose?
It can be a bit overwhelming. Key things to consider are, quality materials, manufacturing tolerances, the seals themselves, price, obviously, availability of kits for your specific car.
What about those ABAC ratings you hear about, like AB3, AB5?
Yeah, ABAC ratings measure precision. Higher numbers mean tighter tolerances. But for RC, super high ABAC ratings aren't always better.
Really? Why not?
The RC environment is rough. Dirt, impacts. Sometimes a slightly looser tolerance, like an ABAC 3 or ABAC 5, can actually be more durable and handle contamination a bit better than a super precise high ABAC bearing. It's about finding the right balance for the application.
Interesting. So don't just chase the highest ABAC number.
Yeah.
Okay, let's talk specific brands. Fast Eddie seems super popular.
Yeah, Fast Eddie has carved out a big space. They hit a really good balance of quality, price, and selection. Lots of vehicle-specific kits. Their rubber-sealed ones are kind of the go-to for many bashers and even club racers. Good reputation.
Then you mentioned Acer Racing. More high-end.
Definitely performance-focused,
Yeah.
known for their ceramic bearings, especially the silicon nitride hybrids. They emphasize low friction, lightweight, fancy cage tech, special oils. Popular with serious racers chasing every advantage.
What about Avid RC? Hear their name a lot in racing circles, too.
Avid is another well-respected brand, particularly among racers. They have their Revolution series bearings, which cleverly use one metal shield and one rubber seal, trying to balance low drag and protection. They offer good quality steel bearings, too.
Boca bearings. They've been around ages, right?
Boca is a long-standing company, high quality, wide range, lots of ceramic options. Can be on the pricier side sometimes, but known for quality.
Any good budget-friendly options? Yeah? Racing?
Yeah, racing offers more affordable kits, often bundled with bearing oil. Good value, especially for that initial Tamiya upgrade. They talk about using aircraft-quality steel. A solid budget choice.
And then you see those super cheap ones online, like dollar bearings.
Yeah, there are definitely ultra-budget options out there. And honestly, for just replacing totally shot bushings in a casual car, they might be okay. But the quality control, the materials, the seal effectiveness, it can be inconsistent. Might not last as long or perform as well as established brands.
So kind of get what you pay for, generally.
Often, yeah. It comes back to matching the choice to your needs.
Like a basher on a budget might grab a Fast Eddie or lacing steel kit.
Makes sense. Good quality rubber-sealed steel.
Club racer may be running a steel spec class. High quality, well-maintained steel, maybe Avid or premium Fast Eddie.
Sounds right. Keep them clean.
Competitive racer in open classes. Looking at hybrid ceramics from Acer, Boca, Avid.
That's where ceramics really come into play, yeah. Seal choice might depend on the track conditions.
And for crawlers, where low-speed torque matters more than super low friction.
Durable, well-greased, rubber-sealed steel bearings are usually the way to go there. Reliability and sealing are key. The ultra-low friction of ceramics isn't really needed.
Perfect. Okay, we've picked our bearings, installed them.
Yeah.
Now, how do we keep them spinning happy? Maintenance time.
Right. Got to take care of them.
Yeah.
Key signs: they need attention.
Yeah.
Gritty or rough feeling when you spin them by hand. Any weird noises, crackling, grinding, whining. Visual rust or damage. Excessive play or slop.
How often do you need to check?
Depends entirely on conditions. Running in mud and dust. Check them after almost every run. Clean indoor track. Much less frequent. Be proactive.
So, check often, especially if you run dirty. When do you clean versus just replace?
Try cleaning first. If cleaning and re-lubing doesn't make it spin smooth again, it's probably time for replacement. Also, replace if you see a pitting or scoring on the races hard to see sometimes, or if the seals are damaged beyond repair, or if it's completely seized or has way too much slop.
Better to replace than risk failure.
Absolutely. Proactive maintenance saves hassle and potential damage later.
Okay, cleaning time. For those 2RS rubber-sealed ones, how do you do it?
Carefully pop the seals off first. Use a sharp pick, a hobby knife tip, maybe a tiny screwdriver. Be gentle, don't bend them.
Seals off. Then.
Degrease and clean. You can use specific bearing cleaner. Electric motor spray works well. Some use brake cleaner, but be cautious with plastics, mineral spirits. An ultrasonic cleaner is great if you have one.
Get all the old gunk out.
Yep. Rinse if needed, depending on the cleaner. Then dry them thoroughly. Compressed air is good. Just don't spin the bearing super fast with the air when it's dry. That can damage it. Or just let them air dry completely.
Clean and bone dry. Now the important part, lubrication. Oil or grease?
Depends. Oils offer lower drag, better for high speed, but they might need reapplying more often as they can fling out.
Okay, and grease.
Greases stay put longer, offer better long-term lubrication, and add an extra layer of sealing against contaminants. But they can have a bit more initial drag. Dry lubes, like PTFE, offer super low drag but need very frequent reapplication.
How much do you apply? Just pack it full?
No, less is more. Over-lubing just attracts dirt and can increase drag. For oil, literally 1 or 2 small drops right onto the balls. Spin it to distribute. For grease, just a small dab worked into the balls.
Sparingly. Got it. Any special sauce for ceramics?
Hybrids, like we said, a light synthetic oil on the races and cages good. Brands like Acer sell their own specific ceramic bearing oil. Full ceramics can run dry, but again, a tiny drop of light oil or dry lube can help with noise and smoothness.
And you can kind of tune with lube. Lighter for racing, maybe thicker for off-road.
Yes, some people do that. Lighter oil for max speed on road, maybe a slightly thicker oil, or a light grease for better protection and longevity in off-road or crawling.
Cool. So lubed up,
Yeah.
then just carefully pop the seals back on.
Yep. Make sure they seat evenly and securely all the way around.
Seems straightforward enough
Yeah.
and worth the effort, right? Ignoring them is a bad idea.
Definitely a false economy. Neglect leads to premature failure, replacement costs, and potentially damaging other expensive parts if a bearing seizes or falls apart. Consistent maintenance is really an investment. Keeps your car running smoothly and reliably.
Couldn't agree more. Okay, let's quickly recap some advice then. For the casual basher.
Good quality rubber sealed, 2RS steel bearings. Fast eddy,
Yeah.
racing something reliable, maintain them reasonably.
Serious off-roader, hitting the mud and jumps.
Durable, well-greased 2RS steel bearings. Maybe check and clean them more frequently. Sealing is paramount.
On-road racer, stock class.
High-quality steel, maybe 2RS or Avid Revolution style. Light oil for low drag. Meticulous cleaning.
Modified on-road racer.
This is where hybrid ceramics really shine. Acer, Boca, Avid Ceramics, lightly oiled, every bit of efficiency counts.
And crawlers and scalers.
Durable, well-greased, 2RS steel again. Focus on sealing and longevity under load, not minimal friction.
Perfect. It really is about the right tool or bearing for the job.
Absolutely. And just to boil down the key takeaways, bearings beat bushings big time. It's often the first best upgrade, especially for Kamiya kits. Ceramic versus steel. Depends on your budget, use case, and tolerance for maintenance and fragility. Seals are crucial. Usually 2RS rubber seals are best for most RC use. Choose reputable brands and maintain them. Clean and lube regularly.
And remember, these bearings are just one part of the whole system, right?
Exactly. Their benefits work together with your motor, your setup, your driving. But understanding them, choosing the right ones, maintaining them, it's a big step towards a better, more reliable, and more fun RC experience.
For sure. And the tech keeps evolving, so stay curious, keep learning. Okay, final thought for you, the learner. We've talked a lot about the precision in these tiny ball bearings. Makes you think, doesn't it? What other, seemingly small, hidden parts in our everyday lives have a similar huge impact on performance and reliability? Things we totally take for granted.
Interesting question.
And maybe, what could we learn from the RC world about actually taking care of those hidden heroes? Something to ponder on your next drive. For the deep dive, thanks for joining us.